Hello, mathematicians. Today we're going to be learning about fractions and decimals, more specifically about converting fractions to decimals, and in this video we'll be focusing on repeating decimals. To get us started, we have 1 over 3. Now, in order to convert 1/3 into a decimal, we have to take the numerator and divide it by the denominator. So 1 divided by 3. That means that our numerator is going to be our dividend and our denominator is going to be our divisor. And then we ask ourselves, how many times does 3 go into 1? Well, 3 does not go into 1, so that would be 0. And that makes sense because 1 out of 3 is less than 1 whole, so our value in decimal form is going to be less than a whole. So we're going to add a decimal after the 1 and add a 0 after it. Make sure you bring up our decimal point. And then ignoring the decimal, we ask ourselves, how many times does 3 go into 10? Well, 3 goes into 10 3 times, and that's because 3 times 3 is equal to 9. So we go ahead and write the 9 here, and then we're going to subtract. So 10 minus 9 is equal to 1. Because we have a remainder, we go ahead and add another 0 and bring it down. Then we ask ourselves, how many times does 3 go into 10? 3 goes into 10 3 times because 3 times 3 is equal to 9. We write the 9 on the bottom, and then we go ahead and subtract. Then we get another remainder of 1. We add another 0, and notice that the same thing keeps happening over and over again. So we're going to add a 3 here because 3 times 3 is equal to 9. And then we're going to go ahead and we're going to subtract. And then we get a remainder of 1. So we could keep going on and on and on, and this will go on forever. And notice here that we have 0.333, and the pattern continues. So here we actually have a repeating decimal, and what's repeating here is the 3. So we write this as 0.3 with a line on top of it, representing that this is a repeating decimal and the 3 will keep repeating over and over again. So 1/3 is equal to 0.3 repeating. Right? So here we have another example, which is 4 over 9. And in order to write this as a decimal, we have to go ahead and divide 4 divided by 9. That means that 4 is our dividend, and 9 will be our divisor. So we ask ourselves, how many times does 9 go into 4? Well, 9 does not go into 4 because 4 over 9 is not a whole number, so our value is going to be less than 1. So we add a decimal point after the 4 and add a 0. Make sure you bring your decimal point up, and then we ask ourselves, how many times does 9 go into 40? So ignore the decimal for right now. Well, 9 goes into 44 times because 9 times 4 is equal to 36, and that's as close as we could get without passing 40. So we do 40 minus 36. We get a remainder of 4, so we add another 0 and bring it down, and we get 40. Well, we know that 9 goes into 40 4 times because 9 times 4 is equal to 36, and then we subtract by 36 again. And notice that the same thing keeps happening. We got a remainder of 4, so we add another 0, bring it down. 9 goes into 40 4 times because 9 times 4 is equal to 36. Now, this is going to go on and on and on forever because we have a repeating decimal. Okay, we have 0.444, and it's just going to keep going on and on and on forever. So we're going to write this as a repeating decimal, where we write 0.4 with a line on top representing that the 4 keeps repeating on and on and on forever. So 4 over 9 is equal to 0.4 with a line on top showing that the 4 will keep repeating forever. All right, so here we have another example, which is 5 over 6. So we're going to go ahead and do 5 divided by 6. So 5 is our dividend and 6 is our divisor. And we ask ourselves, how many times does 6 go into 5? Well, it doesn't, so we're going to put the 0 there. Then we're going to add a decimal point and a 0 after the 5. Make sure you bring the decimal point up so we make sure we have the correct value. Then we ask ourselves, how many times does 6 go into 50? Well, that's going to be 8 times because 6 times 8 is equal to 48. And then we're going to subtract. 50 minus 48 is equal to 2. And then we're going to add another 0 at the end here and bring it down because we have a remainder. Then we ask ourselves, how many times does 6 go into 20? 6 goes into 20 3 times because 6 times 3 is equal to 18. Then we're going to write the 18 and we are going to subtract. Then we get a remainder of 2. So we add another 0 and bring it down and we get 20 again. Well, 6 goes into 20 3 times because 6 times 3 is equal to 18. We subtract and then we get a remainder of 2 again. So this is going to keep repeating again. The difference is the only thing that's repeating here is the 3. The 8 we only saw once, but then the 3 keeps repeating on and on and on forever. So we're going to write this as a repeating decimal where we have 0.83, and the line only goes over 3 because 3 is the only number that keeps repeating over and over again. So the 8 does not keep repeating over again. So 5 over 6 is equal to 0.83 with a line on top, demonstrating that the 3 will keep repeating on and on and on forever. All right, so here we have 3 over 7. And again, we're going to write this as a division problem. So 3 divided by 7, where 3 is our dividend and 7 is going to be our divisor. Then we ask ourselves, how many times does 7 go into 3? Well, 7 does not go into 3, so we put a 0 there, add a decimal point, and add a 0. Make sure you bring up the decimal point to ensure that we get the correct value. Then we ask ourselves, how many times does 7 go into 30? Well, 7 goes into 30 4 times because 7 times 4 is equal to 28. So we add a 28 here, and then we subtract. And we get a remainder of 2. Then we add a 0 and then bring it down. Then we ask ourselves, how many times does 7 go into 20? 7 goes into 20 2 times, and that's because 7 times 2 is equal to 14. So we're going to subtract. 20 minus 14 is equal to 6. So we add a 0, bring it down, and ask ourselves, how many times does 7 go into 60? 7 goes into 60 8 times because 7 times 8 is equal to 56. And then we're going to go ahead and subtract. 60 minus 56 is equal to 4. And so here, notice that we keep getting a remainder. So our answer is approximately 428 thousandths. However, if we did keep dividing, our answer would look like this, okay? If you notice, after a while, we have 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1. So this is actually a repeating decimal, but we would have to go on for a while to see that. So I'm going to write the repeated decimal below that. So that's our repeating decimal. However, when we are dividing, we can approximate and write an estimated answer if it keeps going on this far. Okay? So that's it for converting fractions to decimals. And in this case, we were focusing on repeating decimals.